Hello everyone. Today I will discuss about a drug molecule Escitalopram. This is a very famous drug used as antidepressant medication. This is also used for the treatment of anxiety disorder. Escitalopram drug was introduced in market earlier, and around 13 years later Escitalopram drug was introduced in market. Escitalopram molecule is the S enantiomer of citalopram. Escitalopram has been found to be more potent than its R enantiomer as well as the racemic compound. So citalopram is the racemic molecule. Both the drug actually attained blockbuster status. Especially escitalopram is very famous drug. In the year of 2010, this drug made worldwide market of 1.5 billion USD. The molecule escitalopram was first time synthesized in the year of 1972 by scientist Claus P. Bogesho at Lundbeck Pharmaceutical in Denmark. He joined the company in 1971 and he continued to work in that company for 44 years. So after joining, within 1 year, he synthesized 55 compounds. Escitalopram was one of those compounds. This drug was introduced in Denmark in the year of 1989 and it was launched in US market in 1998. And first successful isolation of the S enantiomer, which is escitalopram, was achieved in the year of 1988. And this escitalopram drug was launched in market in the year of 2002. Now I'll discuss how they synthesized these molecules. They started with this phthalate molecule. They started with bromo-substituted phthalate and did double Grignard reaction. So first Grignard reaction with aryl magnesium bromide to get this ketone. This ketone is actually benzophenone derivative, as you can see. Next reaction was with dimethyl amino propyl magnesium chloride. So it is aliphatic Grignard reagent and they got this dicarbonyl compound. And here they have performed the cyclization reaction using concentrated sulfuric acid followed by cyanation using cuprous cyanide. So they started with bromo substance and finally they converted into that cyanide group by using CuCN. But there was some challenge to perform this reaction in higher scale. So they modified the process again, like after getting this ketone, they have reduced this keto group using lithium aluminum hydride to get this dicarbonyl first, followed by cyclization using sulfuric acid, and then they converted the bromide into cyanide using cuprous cyanide, and the last step they introduced this diaminopropyl group by using this diaminopropyl chloride in presence of strong base sodium hydride. They started this reaction using bromophthalate, considering that if they started with cyanide, it will react with that Grignard reagent as well as it may get hydrolyzed in presence of sulfuric acid. But when they tested with that cyanide phthalate also, surprisingly they observed that after that reaction, cyanide group actually was unaffected completely. So again they modified the process and produced this racemic Escitalopram molecule 5 kg. And when they attempted to do the resolution of this molecule to get that enantiopure S isomer, many attempts using different reagents, different solvent and different conditions actually failed. They tried a lot of things, but actually it did not work. The resolution of this final molecule. So what they tried, after getting this racemic dicarbonyl molecule, here itself they did the resolution by co-crystallization with this D-tartaric acid derivative to get this enantiopure dicarbonyl molecule. And after getting this enantiopure dicarbonyl, they have performed the cyclization reaction using methane sulfonyl chloride in presence of base to get the final molecule. In the year of 2007, actually, Reddy's laboratory reported that resolution of the final molecule is possible under certain condition. So scientists from Lundbeck Pharmaceutical tried the same thing, but they failed multiple times. So they contacted Reddy's Pharmaceutical, and that time Reddy's Pharmaceutical admitted the process actually works with little bit modified conditions, but it was not described perfectly in that report. Later one more modified process appeared, like after getting the ketone, it was complexed with methyl boronic acid in presence of this pseudoephedrine to get this boronate complex, which reacted very selective way with this alkyl Grignard reagent to produce this dicarbonyl with quite good enantiomer purity. Like they obtained 92% enantiopure material. Further enantiomer enrichment was done by resolution using that same D-tartaric acid derivative. Very recently one report came in OPRD journal where they have described synthesis of this molecule in very big scale. Here, when they performed that first Grignard reaction with that aryl Grignard reagent, they did not quench that intermediate, and without any isolation, they introduced that alkyl Grignard reagent and they isolated this dicarbonyl intermediate 3. Here, they have done that resolution using that tartaric acid derivative to get this tartarate salt in enantiopure form, and by using sodium hydroxide they made the dicarbonyl tartarate free. And the final step, they performed the cyclization reaction using tosyl chloride in presence of triethylamine base, followed by treatment with oxalic acid to convert it into the corresponding salt of that final molecule. You can see they started with 446 kg of this phthalide and they obtained 675 kg of the escitalopram molecule. So you can see it's a very big scale production they have done. Thank you.